Alright, welcome back guys. MECH2320, Motor Controls. We're going through Chapter 42, Troubleshooting. Last lecture out of the book here, so everything else lab-based, making sure that we're learning how to wire things up. But with that comes, sometimes we wire some things up and they don't work right, or they were working and then they're not. So we got to go through some troubleshooting to understand, just some simple, step-by-step procedure where we can just a thought process of how to troubleshoot some of the scenarios that might happen. So basically we're going to take and use our multimeter, our ohmmeter, our ammeter, reading voltage, doing those sort of things, because eventually guys, our control circuits will fail, or we wired them up wrong, or something happens and a wire breaks or things like that. Troubleshooting, all right, so that's probably the main job of an electrical or industrial electrician, okay, is you're troubleshooting, fixing, yes, there's new panels and new equipment that go in, or rewiring panels and those sort of things, but the tools of the trade for us is your multimeter. Very, very, very important. And in this industry, it's really important that you have a clamp on ammeter. You're not going to want to use like the little meters that we have in class to measure current, especially with the large horsepower motors and things like that. Okay, so always make sure safety is your first consideration. Always check the applied power and things like that. Make sure you're wearing fire retardant clothing, if it calls for it where you're at. Safety glasses, face shield, hard hat, all those sort of things. Alright, and make sure you're always kind of standing to the side when you're working on stuff. Don't always stand directly in front if something happens. That way hopefully you don't take the full-on repercussion of it. Alright, now here's the main issue here. Test, check, test. Alright, so we're checking the power. Alright, check with the voltmeter. And see if you're getting any power in general. That's the first thing. Make sure the main power is working, and then you're going to go step by step, narrow it down. So you're going to take this big problem and try and whittle it down to a very small problem when you do this. So test circuit voltage to make sure that the correct voltage is on or off, or those sort of things, and then make your check against a known voltage source. Okay, making sure that everything is correct. So remember, we've all done it in class, so I don't need to remind you. You want to look for make sure that if we take it line 1 to neutral, we're getting our full voltage across there that we need to. So you're going to check, am I getting 120 volts, okay, across those 2 points. It's going to be different, right, when we have voltage drops across a different element there, okay, as well as if, make sure you should know what you're reading if the switch is open versus if the switch, is closed. If you're reading across the fuse, right, and you have the multimeter across the fuse, and the fuse is good, your voltage drop should be 0. If the fuse is bad, you're going to get the full voltage drop, so that means something's wrong there. So you got to think about what getting a voltage reading actually means when you're doing that. Okay, so once we do some testing and things like that, causes of overheated load, excessive motor current, high ambient temperatures. It might be really hot in the plant where you're working. All right, different loose connections, incorrect wire sizes. A lot of it's wires have fallen out, and the problem is if you've had 5 to 10 different people working on it over the years, there's some inconsistencies there as well. All right, next, check the current, and this is why I was really emphasizing get a clamp meter, because remember, to read current, with our multimeter, you have to become part of the circuit. With the clamp meter, you can literally clamp it with a wire, and based on the magnetic field, it will tell you how many amps are going through that. A much safer way to check, okay? Notice they're also not checking here with like their bare hands and that sort of thing. You want to make sure that you're wearing as much non-conductive material as possible when you are inside a panel. Something could arc to you, all right? Safety first, because that stuff bites and that hurts. So check all the power or the current that's running to all the individual motors. So here's how, a good rule of thumb for you. If your ammeter indicates the normal operating current across pretty much every line, right? 46.1, 45.8, 45.9. Those are all pretty good, pretty consistent. Okay? Then what if your ammeter reads, much higher than what it should be running at? Well, that means our motor's overloaded. So something's making the motor work too hard because it's drawing more current. And then how do we know if we have a short? Well, if we have two lines that are really high and one that's really low or lower than normal, only operating normal, that tells us there's a short. So there's a way to tell if we're operating normal, operating overloaded, or operated with a short winding. Okay, so let's go through another way of testing. Okay, example 2 here. If we want to test, we can test for continuity. All right, so you can ohm it out, and remember, if it's open, you're going to have an open load or an infinite resistance or an open load resistance. Or if things are working properly, you're going to get a very, very small amount of resistance. You can also check using the continuity switch on your multimeter too. Remember, if we put the two leads together, it makes that little beeping noise. Same thing, if the wires are connected properly, we're going to get that little beeping noise letting us know that there's continuity. So you can use the ohm meter piece and read the resistance, or you can actually use the continuity piece, okay? You can also check the voltage. Okay, make sure you're checking the voltage across all the different components, and check what happens to the voltage when you actually press the switch as well, not just with the switch open. So make sure you're getting the voltages you should. Okay, let's look at another example here. If we had a motor that accelerated to a second speed but never increased to a third. Remember, this is kind of the last few things we were talking about. We got to start, taking a look at our speed contactors or our timer relay. So these are going to be some of the reasons or where you would look. All right. So contactor 2 is defective. Timer contactor TR2 did not close. The timer relay is defective, right? The control relay or the speed relay coil, they're connected in series with the timer. Okay. Or the timer relay 2 didn't close. All different reasons why this might fail right here. So how would you want to do it? All right. So check for voltage across the speed relay coil. Make sure it is or isn't there. Depends on the scenario that's going on. And then check for voltage across pins 1 and 3 of the timer relay. Is the timer relay working correctly? If it's open or closed. So you really got to check into those sort of things, and really strive to make sure that you're narrowing it down. So like this example, I'm going to back up a couple slides. Right, it's talking about that it didn't accelerate to the second speed, or I'm sorry, it made it to the second speed but didn't get to the third speed. So that's how you know where to start looking on these. All right, we're not going to be looking up at the first speed stuff or the second speed stuff potentially yet. You're going to start what's not working and work your way backwards as you go through these. So just always come up with a plan of how you want to approach the problem, and then work your way through it. So start from the bottom and work your way back up through the controls if we're having issues with the last part. Okay, take your readings. So just remember, all right, the circuit control, right, that's intended to control the motor's operation. So you're really just checking for open loads, or making sure everything's closed when it should be closed, open when it should be open. You're getting the right readings, you're getting the right currents, and the continuity's there, okay? But the fastest way, in general, to troubleshoot everything is to measure the current in each of the lines supplying power, okay? Because sometimes the windings themselves could be the problems, okay? And if you would do that and you measure things to be significantly different in value, definitely the windings, okay? And then just general stuff that causes the motor to overheat in general, mechanical issues, poor ventilation. We run into that sometimes when you guys use the cutting tools or things like that. You're covering up the vents, and the motor can't cool off fast enough, and you actually overheat and ruin the motor. All right, wrong wire sizing, and it was very important. We talked about that in a prior chapter about going through like the NEC code and making sure that based on the current draw, if you don't have the right current size or the right wire size, the current's going to melt that wire, overheat it, and you could even pop the wire and things like that. The motor's undersized for the load, right? It just can't handle. It doesn't have the torque or the power necessary to move the load. When you weak it, and eventually the motor crumbles because it's drawing so much current, but it can't physically move the load. It can't overcome it, okay? Over or under voltage, all right? And then unbalanced voltages. So just some things to think about. As you guys gain more experience in industry, these things will become more second nature to you. You're going to learn from the people that have been doing it for years, and they're going to kind of show you how to walk through all of that and do all that as well. So definitely, yeah, there's some book learning to this, but a lot of this learning goes, in hand with working on a daily basis and being in and around a lot of this stuff. So anyhow, that's the end, guys. It's been a great class. Like I said, as usual, let me know if you have any questions. Else, I'll see you in class, and remember, this is the last lecture, so don't do anything I wouldn't do. I'll catch you guys later. Have a great day.